The night feels deeper when the lights are low and the world has stopped asking for things. In that hush, I like to think about the edges of our solar system, the places the sun only brushes with a faint touch. Out there, in the long, cold, drift the forgotten planets, small, pale worlds of ice and shadow, circling slowly through the dark. They glow just enough to be remembered, like old friends seen through frost-blurred glass. Their names are quiet now, their stories softer than starlight. Yet they keep watch, keeping time for a universe that never truly sleeps. If you'd like to stay in this quiet space with me, a gentle like, a soft subscribe, only if it feels right. Now, let your shoulders ease and let your breath find its rhythm. We'll begin our journey together through the quiet universe. What else might be breathing out there, past the warm lanes we know by heart? Most of us picture the solar system as a bright procession, Mercury to Neptune, a tidy necklace circling the Sunday. Beyond that, minds go dim where the light goes dim, and it can feel as if the map simply stops. It doesn't. The story keeps drifting outward for billions of kilometers, into a hush where ice keeps its counsel and sunlight thins to a sleepy silver. In that slow, dark live the forgotten planets, small, ancient bodies, some round as careful pearls, others lopsided, like stones from a riverbed. Their years are long, their daylight faint, and their paths are quiet loops written far from the hearth. They were born from the same dusty swirl that raised the big worlds, just never fed enough to grow grand. For a long time they hid in plain night, overlooked because they moved too slowly and gleamed too softly, their voices too subtle for busy eyes. Yet they hold the early chapters of our neighborhood tucked inside their ice and rock, the first scribbles that became continents and oceans and rain. They are the fossils of planet-making, the almost worlds. Some carry thin veils of gas that come and go with the cold. Some keep tiny moons, like crumbs in a pocket. A few still reshape themselves in the dark, heat leaking up in whispers that write new lines on old faces. Their orbits are stretched like sleepy rubber bands, tugged by giants, pulled by time. Reading them is like reading tree rings by starlight, slow, patient, and strangely tender. Between Mars and Jupiter, where broken stone drifts in a broad, faint band, another quiet world waits. It is small for a planet, large for a rock, and for a brief moment in our history it wore a bigger name, Ceres. The only dwarf planet of the inner solar system, and the heavy heart of the asteroid belt, nearly a third of its total mass gathered into one shy sphere. Under the weak sun, its surface reflects a little more light than its neighbors, a soft sheen that hints at something beneath. A winter night opened the century of its discovery. On the 1st of January, 1801, an Italian astronomer, Giuseppe Piazzi, noticed a point of light that refused to sit still with the stars. Night by night it crept, a small traveler with its own plan. He believed he had found a new planet. For a time, everyone agreed, and schoolroom charts tucked Ceres between Mars and Jupiter, as if it had always lived there. But more wanderers appeared. Pallas, Juno, Vesta, and Ceres began to look less like a lone world and more like the largest pebble on a long gravel path. By the mid-1800s, it had been quietly recast as an asteroid, and its name slipped out of common speech. The sky, however, kept its own record. Ceres isn't just another lump. It gleams because ice lives in it, water bound into the crust and mixed through the regolith like frost in dark soil. Some of that water may still be mobile in briny pockets below the surface, ancient and cold. Now and then, the deep seems to touch the day. When NASA's Dawn spacecraft arrived in 2015 and began its careful spirals downward, it saw bright pinpricks inside a wide basin named Okator. They looked like spilled moonlight, startling against the gray, a scatter of white as sharp as salt on slate. Up close, the patches resolved into deposits rich in sodium carbonate, the residue of briny water that had seeped upward, frozen, and left behind its shining salts as the last dampness evaporated into space. They are postcards from within, proof that even here, in the belt's soft silence, the interior has not entirely fallen asleep. The mountain called Ahuna Mons rises nearby, a solitary shape with clean sides, pale in the mild Sunday. It does not look battered enough to be ancient. Its youth, perhaps only a couple of 100 million years old, whispers of cryovolcanism, eruptions that trade lava's fire for icy slurries, muds, and salts. Imagine a slow, cold fountain that bulges, freezes, and sags. Not a violent blast, more a steady exhale. Ahuna feels like that exhale, a frozen syllable that tells you Ceres still has breath. Daylight here is gentle. At Ceres's distance, sunlight is only a small fraction of what warms our afternoons on Earth. The ground brightens, but never blazes. Shadows are long and calm. The thermometer rarely lifts beyond the bitter edge of 40 degrees Fahrenheit, roughly 40 degrees Celsius, in the warmest spots, and most places stay far colder. Night is sharper still, stars pricked into a black that an atmosphere never softens. No wind, no rustle, even dust is reluctant to stir. The little strikes of micrometeorites are the tick of a clock that has run for billions of years. Gravity barely holds your ankle. At about 3% of Earth's pull, a careful step would bloom into a soft float before your foot returned. Drop a pebble, and you could count heartbeats before it kissed the ground. Nothing here hurries. Not the light, not the dust, not the slow, inward settling of a world still arranging itself. Ceres stands at a seam. To one side lie the compact, rocky planets that learn to melt and sort themselves into cores and mantles. To the other loom the giants, rich in hydrogen, ringed and teeming with cold chemistry. Ceres feels like a seed that never found the rain. In the earliest days, had Jupiter not swollen so quickly, this little body might have gathered more, grown a thicker crust, a stronger heat, perhaps even a thin, lasting atmosphere. Instead, it remains a planetesimal, a lovely word for a small beginning caught between realms, half-finished and wholly valuable, because beginnings keep records. The water, salts, and carbon compounds in and on Ceres are kin to the ones that fed our own world. Long ago, objects like this may have delivered water to Earth, scattered by impacts into basins that became seas, each splash a gift, each grain of carbonate a footnote under the word life. Its path around the sun is unshowy and dependable, about 4.5 Earth years for one turn. The spin is quicker. A day on Ceres lasts about 9 hours, so sunrise and sunset come and go with a sleepy regularity. Even while the sun remains faint, the numbers feel like a lullaby, more than a ledger. 4.5, 9, small counts, easy to hold in the dark. Stand in imagination on those dusky plains. The sun is a bright coin far away. Earth is a frail blue pinhead, lovely and distant. The horizon curves close, reminding you that you are on something modest, something you could walk around in a lifetime If you had the air and the time, no sound reaches you from the landscape. Only your breath inside the helmet, the soft thump of your pulse, the hush of your suit's systems. Okata's bright patches would be visible as pale stains on the inner wall of a wide bowl. Ahuna would cut a clean wedge against the sky, not tall by mountain standards, yet more than enough to reorder your sense of scale. Everything feels simple and exact. A place reduced to essentials: light, dark, ice, stone, time. Ceres carries the mood of a memory, not the kind with banners, but a quiet page pressed flat between chapters. It remembers the hot, crowded beginning when rocks collided and clung, the way Jupiter's growing pull rewrote the neighborhood, the steady rain of comets, and the slow fading of heat. While the inner worlds melted and remade themselves and one of them learned to dream, Ceres kept circling, keeping a ledger of first ingredients. It lives between big and small, rock and ice, past and possible. That in-between is its gift, proof that half-finished things can still teach, that gentleness endures, that a small light is enough to read the oldest lines. And once you've learned to read by that light, your eyes adjust to dimmer rooms, and the path naturally leads outward past the warm lanes of the giants, to where the sun thins to a whisper, and motion itself becomes a kind of shape, far past Neptune's soft blue edge. In that hush, a stretched world turns with quiet urgency. Gravity usually teaches roundness, but here the lesson took a different form, as if invisible hands had drawn the poles apart and set the body into an elegant oval, more silver seed than sphere. Haumea spins as if keeping a private promise, about 6 times per Earth day, a full turn in roughly 4 hours. The haste is its sculptor. At the equator, the outward tug loosens the hold of weight, and the whole world settles into a graceful compromise between flying apart and staying whole. It is what Ceres hinted at in softer tones: memory you can measure, motion you can see carried to the far edge, where speed becomes profile, and a single idea turns a small, cold world into a signature. Long ago, when the solar system was still clearing its throat, slow collisions were common. Ice and rock trading momentum, fusing here, shattering there. A glancing blow may have struck Haumea off-center, gifting it that relentless spin, and perhaps peeling away fragments that didn't return. 2 of those fragments may now keep it company, moving like devoted lanterns in the dim, Hihiyaka and Namaka, tiny moons with gentle names, tilting and nodding through space. They do not dominate the sky the way our moon does from Earth. They are closer to glints, companions in a dance you could watch all night without ever hearing a sound. Rings circle this distant body, too faint, thin, and dark, like a charcoal pencil line drawn above the surface. They hang at a sensible height, about 1,000 kilometers up, a narrow band of rock and ice, sifting sunlight into a soft halo. Not many worlds beyond the giant planets wear such adornments. Here, in the far cold, a ring feels like an afterthought the universe decided to keep. Debris from the old impact, perhaps all material gently ground from small satellites and never allowed to fall. From a distance, the composition reads as a single shimmering system, elongated world at the center, delicate ring like a whisper, 2 little moons moving to a rhythm only they and their parent share. The face of Haumea is bright, astonishingly bright for a place so remote. Sunlight that looks thin and tired by the time it arrives still bounces back with crispness, as if striking snow laid down in the last hour of winter daylight. When astronomers split that light to read its signature, they find the telltale print of crystalline water ice. Something renews that frost. Perhaps micrometeorites churn the surface into fresh sparkle. Perhaps tiny exhalations bring buried ice upward, where it can refreeze into clean crystals. The sheen makes Haumea look deceptively young, a veteran dancer in a mirror-bright costume, steps practiced, face serene. Under the ice, density hints at a mixed interior rock for a core, thick ice around it, arrangements learned from years of quiet settling. Heat out here is sparse, but not non-existent. The energy left from formation, the gentle pull and press of tides from its moons, the slow decay of radioactive elements in the rocky heart, all could add a thread or two of warmth, enough to soften some layer for a time, enough for the world to sigh and smooth its skin. Nothing dramatic, nothing that would crack the night, just the kind of housekeeping a small planet does without drawing attention. The sky above would look clean and intent, the sun, a bright coin you could cover with a thumbnail, the stars hard as pinpoints. A day would be brief, one sweep of light and shadow every 4 hours, and the ground underfoot would curve in unfamiliar ways, edges bending sooner than your instincts expect, because the world is small and the horizon is close. Gravity would be kind, a gentle pull far less than Earth's. A step would lengthen of its own accord. A hop would become a slow, surprised float. And at the equator, the rapid spin would add a whisper of outward ease, like leaning into a swing at the top of its arc. There would be no wind to push at your suit, no rustle to claim space for sound, just the quiet click of instruments, the human metronome of breath, the thin shadow of your shape skating over ice that remembers ancient impacts. Haumea's year is unhurried, about 284 Earth years, to complete its grand loop. Most of that time it spends among countless other icy relics, leftovers from the solar system's early work, each carrying a variation on the same tune. Methane and nitrogen here, water and rock there, a touch of carbon compounds darkened by the weathering of light. In this crowd, Haumea stands out not only because it is large, not only because it is bright, but because it refuses to settle into the roundness that gravity usually insists upon. It has found another kind of balance, not the stillness of a stone, but the poise of a dancer, motion held so steady it becomes a kind of rest. Out in the same cold sea, a smaller ember drifts redder, quieter, patient in a different way. Make carries a name with a soft rhythm, a gift from the Rapa Nui people, a creative figure folded into a very distant world. It was first noticed near Easter in 2005, when careful watchers followed a faint dot that did not obey the background stars. In a sky populated with dim, charcoal objects that swallow most of the light that touches them, this one returned a subtle copper glow, as if old metal had been polished by starlight alone. Make is small compared with the major planets, and even with Pluto, on the order of 2/3 Pluto's size, but large enough to rule its patch of space. Its surface is a palimpsest of frozen methane, ethane, and nitrogen, layered like delicate frost upon frost. At temperatures around 200 degrees Celsius, even gases choose to be stone. Over spans of time that outlast languages, ultraviolet light and cosmic rays work on those simple ices, rearranging molecules into more elaborate chains. Tholins, a word that sounds like moss and ink. They are not life, but they are chemistry that could be useful to life. Dark, sticky organics that settle into grains, tinting the world a rusty red. Color becomes a clock here. A deeper hue means the surface has been left mostly undisturbed, allowed to age under a slow drizzle of radiation. Every pinkish shadow hints at years piling up quietly. If you could kneel and scoop, the stuff beneath your glove would likely crumble like powdered ice, catching the weak sunlight in a million tiny sparks. The ground would not be a clean, field white snow. It would be darker, richer, a red-brown blush dusted with brightness, a paradox of sheen and shadow. Footsteps would be weightless things, bouncing a little as you moved, because the world hardly insists on holding you down. Its gravity only a handful of % of Earth's. A stride would feel like walking through a memory of a playground. Lift, float, land. You would cast a precise, long-armed shadow across level plains, your outline thin and careful under a small, brilliant Sunday. Air, if one can call it that, is a visitor here. When Make creeps nearer to the sun along its elongated path, some of the surface frost breathes out methane and nitrogen, sublimating straight into gas, forming a veil, too thin to make a sound, too fragile to have weather, yet enough to change how light passes. Later, as the world strolls back into deeper cold, that veil falls again, snowing itself onto the ground molecule by molecule. It is an atmosphere that knows how to come and how to leave. A sky that is more ritual than presence. A pulse that shows the surface and the sun remain in quiet conversation. For a long while, Make seemed to move alone, but no world likes to be completely solitary. In 2016, astronomers spotted a small moon tucked close to Make's glare, a faint companion that had hidden in the brightness. For now it goes by the placeholder MK2, roundabout in its path, modest in size, something like a stone lantern hung near the main door. Watching the moon's orbit lets us weigh the parent world more precisely, turn brightness and size into density, turn density into guesses about rock and ice, core and shell. Even at the edge of the sun's reach, you can learn about the inside of a place by observing the step of the dancer beside it. Make's clock ticks slowly. It needs about 305 Earth years to complete its orbit. The sunlight that warms it left the sun more than 7 hours earlier. From the surface, the star at the center of everything would not be a warm disk, but a brilliant point that demands a squint. The sky would be black and exact, unsoftened by air. Stars arriving with razor edges, constellations rendered with a precision that would make your chest feel both broad and small. The day would be an unscrolling of dimness and glint. The night would be a jeweled cloth. Neither would raise a wind or darken into cloud. The charm of Make is not in spectacle. There are no opaline rings wide enough to fill the sky, no storms striped like muscles across the face. Instead, there is the steady patience of a world that keeps chemistry like a hope in its pocket. Those tholins, those frozen gases that learn to be solids, tell us what the solar system's ingredients looked like before they were kneaded into planets, before heat and pressure tucked them away behind crusts and seas. They are time capsules written in red. The idea that such a quiet place can safeguard the first lines of the recipe for oceans and air and maybe even biology that comfort fits the night. These two, so different in mood, one bright, elongated, and quick, the other ruddy, rounder, and reserved, share a home in the frozen outskirts, where most things move with deliberate calm. Haumea refuses to slow, turning its spin into shape, wearing a ring like a line of poetry, and shepherding two small moons in tilted courses. Make keeps its counsel, letting the sun switch on a ghostly shawl of air and then take it away, letting radiation paint its face one slow layer at a time, letting a small moon play archivist for mass and density. Both remind us that the solar system is more subtle than the textbook parade suggests. Balance can be round and still. It can also be fast and stretched. Silence can be empty. It can also be full of chemistry, busy at a pace too patient to watch. Imagine the sun as a hearth you can barely see from down the hall. Near it, worlds simmer, churn, traffic in storms and heat, and voices of magnetic fields. Farther out, the hallway cools and quiets. In that cool hush, a world decides to whirl for joy, to keep time with itself, and another chooses to redden and thicken its surface with ancient sunlight, to gather building blocks where nothing else seems to happen. The contrast is soothing. The lesson is gentle. Not every world chooses stillness. Not every world chooses noise. They find their own tempo and keep it for centuries. Stand again for a heartbeat on Haumea's equator. The ground slides away at the edges. The day slips by in a 4-hour blink, and the ring too thin and dark to catch threads the sky just beyond sight. Step in imagination to make makes plain. Your boots bite into a mitten of red dust veined with ice. The sun is a hard jewel. Your shadow falls razor clean. You lift a glove, and tiny sparkles answer light, fastening itself to grains that have waited for ages. Then the scene softens, and you're back on Earth. Breath warm with the ordinary night hum. The outer worlds keep circling, not forgotten at all, writing quiet lines no storm can smudge. They don't ask to be grand or first. They carry beginnings and keep them safe. Knowing they're there, spinning, drifting, bright or ruddy, unhurried by our clocks, lets the room feel gentler. And because attention, once trained on the subtle, starts to notice shape in the dark, your gaze follows one more thread outward, toward a world whose very being asked us to revise the labels on our shelves. Far beyond Neptune, where daylight thins to a pale ghost and the stars sharpen against the black, a quiet world rewrote how we sought the sky. It didn't roar or beckon. It simply persisted, cold, dense, undeniably there, and by existing, it pushed our language closer to the truth. Eris, a shade smaller than Pluto in width, yet heavier, rock-rich, wearing distance like a cloak. When a team led by Mike Brown first noticed it in 2005 at Palomar, many greeted it as the 10th planet, a neat story that fit easily beside Pluto. But neat stories can blur edges. The clearer one was kinder to the cosmos, if not to tidy lists. This new neighbor didn't just add a name, it revealed a crowd, and with it, the need to let our definitions breathe. Numbers arrived and jostled for space in the conversation. If Pluto was small for a planet, and Eris was about the same size, maybe a touch smaller in diameter, but heavier by a clear margin, around 27% more massive, what exactly was a planet? A question that had been humming for years rose to the surface and found a room to speak in. If Pluto counted, did Eris count? If Eris counted, what about the dozens, perhaps hundreds, of icy worlds in the Kuiper Belt, and beyond that share crowded neighborhoods and tilted paths? The neat row of 9, memorized by so many children, began to wrinkle at the edges, like an old map exposed to fresh air. In 2006, the International Astronomical Union put words to the distinction. To join the family as a planet, an object must orbit the sun, must be massive enough for its own gravity to pull it into a nearly round shape, and must have cleared its orbit, swept up or dominated the other debris near its path. Pluto and Eris satisfied the first two. The third they did not. Their lanes remained busy, shared with other icy wanderers. With that, Pluto moved into a new, smaller fellowship dwarf planets, and Eris took its place beside it, not as a usurper, but as kin. The decision stirred feelings far from telescopes. People wrote letters, staked protests in ink and in classrooms, argued gently over dinner tables. A name floated around that fit too well to ignore. Eris, goddess of strife and discord, an affectionate wink at the commotion one quiet world had caused merely by existing where it always had. The world itself is not theatrical. About 2,320 kilometers wide, only a little narrower than Pluto, Eris lives in a slow ellipse with an average distance beyond 10 billion kilometers from the Sunday. One circuit takes about 557 years. At its farthest, it strays to nearly 3 times Pluto's greatest remove. Light needs almost 9 hours to make the trip from the sun to its surface. Warmth arrives as a whisper and becomes frost. Temperatures around 230 degrees Celsius still the surface into a glassy patience. Nitrogen ice likely claims broad fields. Patches of frozen methane add sheen. This reflective icing makes Eris among the brightest bodies out there, tiny and diamond-sharp in a telescope, a steady glint against the soft wash of deep space. Eris keeps a companion, a modest moon named Dysnomia, after the daughter of the very goddess her parent world recalls in myth. Dysnomia is roughly 350 kilometers across, and loops Eris at a measured distance of about 37,000 kilometers. By watching that calm revolution, astronomers could weigh Eris with care and confirm what hints had suggested. Despite being a touch smaller than Pluto in diameter, Eris carries more heft. Together, the pair resemble a frosted pear, rolling in slow motion, their bond steady, their conversation silent. Imagine standing near the boundary of a shallow crater there. The sun is a hard point, not a disk. Noon brings no blue, only a deeper black, pinned with precise constellations. The ground is hard and pale, a glaze more than a powder. Each step crunches with a dry crackle like thin ice under boot. Gravity invites you softly, about 8% of what you know from home. Walking becomes a series of careful bounds, a dance at half speed. No wind comes to test your balance. No atmosphere moves to carry a sound. You hear breath, heartbeat, the whispers of your suit, and beneath all that, nothing. Eris is a place that holds its breath and never quite exhales. Yet by sitting in that breathless stillness, by being exactly what it is, Eris shifted the furniture of our understanding. It did not dethrone Pluto. It did not plot. It simply became the moment we notice the mismatch between categories and nature. The humor of it is tender. A frozen bead almost 9 hours of light time away becomes a spark for arguments among warm-blooded creatures, crowded a few steps from the Sunday. Over time, the arguments softened into acceptance, and Eris remained what it had always been: bright, steady, patient, useful, precisely because it insisted on being itself. Astronomers now place Eris within the scattered disk, a realm beyond the familiar Kuiper belt, where orbits lean and stretch, where paths look like ellipses tugged at odd angles. These bodies may have been flung to their current distances by Neptune's gravity early on, or jostled by the nudges of passing stars when the sun was young and traveled with its stellar siblings. Studying Eris and its kin is like reading the margins of a very old manuscript, notes that explain how the main text came to be. Why did some objects settle near the giants, while others were cast farther into the cold? What do composition and orbit say about the crowded, colliding centuries after the solar system lit its first fires? Eris answers not with speeches, but with presence. It proves that size alone is not the storyteller. It shows how definition can change without the world itself changing at all. It leaves room for wonder, for a count of thousands rather than a poster's neat 9. It glides on, indifferent to our debates, content as a punctual fleck of light that keeps the time of 5.5 centuries and demands nothing from us except the courtesy of attention. Beyond the Kuiper Belt's feathered edge, past the scattered disk's long ellipses, past the places where even the giant's gravity loosens its authority, another wanderer arcs through a darkness that feels mythic. Sedna. Its name moves through the mouth like a tide, soft, certain, slow. If Eris made us reorganize our shelves, Sedna made us widen the room. It is one of the most remote objects we have ever found bound to our Sunday. While familiar planets and many dwarf planets count their years in numbers we can pronounce easily, Sedna's year requires a deep breath, roughly 11,400 Earth years for a single orbit. It is a pilgrimage more than a path. Sedna entered our awareness in 2003. Again through the patient craft of Mike Brown and collaborating eyes. The astonishment came not from its size, it is smaller than Pluto, but from the vastness of its route. Even at its nearest, it does not approach the Sun closer than about 76 astronomical units. Neptune lives near 30. At its farthest, Sedna drifts beyond 900 AU, nearly 100 times farther from the Sun than Earth. From there, the Sun is not a round warmth but a bright pin, a little fiercer than the other stars, though only barely. The idea of a solar system that ends neatly at Neptune frays here, thread by careful thread. Sedna's orbit doesn't sit politely in the Kuiper Belt's flat ring. It belongs to something else, perhaps the inner edge of a vast, ghostly sphere called the Oort cloud, a repository of icy bodies that may surround the solar system in every direction. If that guess is right, Sedna is an ambassador from the deep freeze, the first envoy we have met from a region that has watched the Sun from very far away for a very long time. To look at Sedna is to imagine a halo of quiet objects, a slow crowd that has not cared what we call it and has not needed language to keep its patience. The world itself wears red like old lacquer. It is among the reddest objects we know, deeper than Mars, deeper than Makemake. A color built not from iron dust but from chemistry rewritten by radiation. For billions of years, cosmic rays and ultraviolet light have played a spare music on simple ices, methane, nitrogen, other small molecules. They stitch the pieces into long, dark chains, tholins coating the surface over and over until the color sinks in. This is not the ruddiness of youth, it is the stain of time. The cold is severe, even by outer system standards, something like 240 degrees Celsius, so extreme that gases we breathe on Earth turn to stone here. Any atmosphere Sedna might have once had would have fallen back as frost long ago. The airlessness makes the stars painful in their precision. There is no haze, no murmur, only the immaculate geometry of constellations cut into hard light. Walk there in your mind. The Sun is a brilliant point that refuses to grow larger. Shadows are razor-edged and long, sliding across a surface, the color of dried wine stains and winter peat. The ground would crunch with a peculiar firmness of ice that has forgotten water's softness. Gravity is very gentle, on the order of 5% of Earth's, and each motion would feel like a choice between floating and returning. Day and night would stretch until the words feel thin. Time would become a trick of light angles and star positions because nothing else moves in a way the body recognizes. How did Sedna find such a vast ellipse? Stories abound, each told softly because the evidence we have is thread-like. Perhaps, when the sun was young and lived in a cluster, a passing star leaned in close and tugged Sedna outward, like a sleeve catching on a nail and pulling the fabric with it. Perhaps an unseen giant, Planet 9, some have called it, lurks far beyond Neptune, shepherding distant bodies into stretched orbits with a patience that shrugs at centuries. Or perhaps Sedna formed out there, at the very fringe, where the sun's gravity is a suggestion rather than a command, and it is simply kept to its deep circle, unbothered and unseen, until our instruments grew keen enough to notice its glint. Whatever the origin, the consequence is clear. Sedna is a time capsule, a museum with no guards and no doors, where the exhibits are simply the surface and the scars. Geology, if it ever stirred, has slept for ages. What you see is what has been written by the slow rain of space and the occasional distant tap of an impactor that wandered too far. Each crater rim is a syllable. Each ridge is a margin note. Sedna records weather that has no wind and seasons that are defined by distance alone. The scale of its year invites perspective. The last time Sedna swung near the sun, mammoths still shouldered their way across cold grasslands, and human hands were just beginning to paint stories on stone. When it comes close again, the language naming it may be dust, or may be something we cannot yet imagine. Sedna keeps millennia the way we keep minutes. It circles our star so slowly that a lifetime is thinner than a mark on a timeline. It is as if the solar system breathes once while Sedna moves through a fraction of an exhale. Even Pluto, patient as it is with its 248-year loop, looks quick beside this crimson pilgrim. What Sedna offers is the comfort of scale. The solar system is not just a centered clock with evenly spaced ticks. It is a family with cousins who live far away, a household with attics and cellars, a boundary that blurs into countryside and then into a barely drawn line. Some objects receive enough sun to make weather. Others receive so little that weather becomes a metaphor instead of a process. These remote bodies are not part of our routine sky. They are part of our memory, a record of how the neighborhood formed, and a clue about how it reaches into the dark. To think of Sedna for long is to feel a kind of calm settle. It does not hurry. It does not flash. It glows faintly and goes on. The patience is instructive. In its long stillness, Sedna shows that change need not be the only story. Endurance is a story, too. While comets flare and fade, while inner planets trade seasons and storms and plates, Sedna holds its course like a quiet vow. It asks no attention, but accepts it if offered. It offers no warmth, but keeps a kind of warmth of meaning. The reminder that time can be slow and still be time. That distance can be vast and still belong. If you trace Eris's path across the dark, with your mind let the orbit unwind like a slow thread, you begin to sense the scale of what the sun still holds. Near its hearth, light is loud and crowded. Everything hums with heat and hurry. Farther out, the air, or what stands in for air, grows spare and still, and the noise falls away until only motion itself remains. Farther yet, the hallways are paved with frost, and the only sound is the steady tick of distance itself. Eris walks one of those corridors, bright, compact, a lesson sealed in ice. Beyond even that, Sedna drifts through a red courtyard of night, beautiful in a way untouched by us. its orbit so long that history barely fits inside a single loop. Here at home, the air feels warmer for knowing such cold exists. Those two worlds continue without our witness or permission. Eris glitters and measures centuries. Sedna deepens and measures millennia. They move outside the cadence of our lives, and by doing so, make those lives feel more spacious. Together, they hum the same quiet refrain. The solar system is wider than our first stories, older than our first names, and gentler with its mysteries than our neat definitions ever were. We can love Pluto and still learn. We can change a word and still keep wonder. We can look toward what we once called an edge and find that it isn't one at all, only a farther field where sunlight arrives as a whisper, and the dark is clear enough to read by. And in that far, whispering field, the pattern continues. Past Neptune's pale edge, where the sun shrinks to a coin and the constellations feel newly cut, another balance holds steady. A small world moves in step with a larger story, not shouting, not lagging, just keeping time with a partner it will never touch. Astronomers call it Orcus, sometimes the anti-Pluto, not as a slight, but as a kindness, a way of describing how its path mirrors Pluto's from the far side of the system. When Pluto leans sunward, Orcus leans away. When Pluto drifts into cold shadow, Orcus answers by gliding inward. They share a rhythm called resonance, an old clockwork kept by Neptune's pull. For every 2 laps they make, Neptune makes 3. It is a long, careful waltz that has lasted for billions of years, quiet as breath, flawless as trust. Orcus was first noticed in 2004 by Michael Brown, Chad Trujillo, and David Rabinowitz as nothing more than a dim moving speck against the steady field of stars. Patient follow-up turned the speck into a world, about 910 kilometers across, roughly half Pluto's diameter, a mixture of ice and rock, with darkness settled onto its skin. It reflects only about a fifth of the sunlight that touches it, an old ember's sheen rather than a mirror's glare. Radiation has been writing on its surface for eons, breaking simple ices into complex organics called tholins that stain the frost a brown-gray, the color of weathered wood after winter. Beneath the skin lies what most of these far travelers carry: water ice, a touch of methane frozen into place, carbon compounds folded into the crust. It is the pantry of the early solar system, sealed, labeled only by color. Orcus keeps company. In 2005, observers found a moon circling it, Vanth, a name borrowed from Etruscan myth, a winged guide who accompanies souls without fanfare. The fit is quiet and perfect. Vanth is unusually large compared to its primary, nearly half Orcus's size at about 475 kilometers across. The pair could be called a binary, 2 bodies orbiting a shared center, partners, more than leader and follower. Vanth's color leans redder than Orcus's, hinting at a different mix of surface ice and organics, maybe a separate origin. Did a collision lift Vanth from Orcus long ago, freezing debris into a companion? Or did Orcus capture a passing wanderer that happened to match its pace? The sky does not answer, but the two keep circling each other every 10 days or so, a rusty pearl looping a dark stone while the far sun watches like a lantern at the edge of a field. Seasons here do not turn the way they do at home. Orcus's orbit is inclined, and its axis may be tilted as well, which means its poles could linger in low sunlight for centuries, then surrender to centuries of night. Ice has time to wander. In the weak warmth, molecules lift from the lit pole and drift, later to settle and refreeze in the long dark. Over millennia, Frost migrates like nomads crossing a desert, pole to pole, patient as dust. Time itself feels heavier at this distance. The usual units, hours, days, lose sharpness. Epochs begin to feel like the proper measure for weather. The cold is not a mood here. It is a property. Orcus lives around 6 billion kilometers from the Sunday. Even on its brighter days, temperatures hover near 200 degrees Celsius. A thin crust of volatile ice overlays a denser interior, and some scientists suspect a darker secret, buried deep slush held just above freezing by the leftover heat of formation, or by the slow kneading of tides from Vance's Pull. If so, a hidden ocean may persist in pockets, a tiny echo of warmth folded into ice that otherwise refuses to move. Nothing dramatic, more like a steady heartbeat under a heavy blanket. Through telescopes, Orcus is kinder than you'd expect. Its steady brightness made it easy to follow, and its path on the star field drew a clear arc that matched the resonance we knew from Pluto, a choreography that speaks of the giant Neptune's influence and the delicate stability that comes with it. While Pluto has become the outer system's celebrity, its heart-shaped plane photographed in daylight by a passing spacecraft, Orcus remains a distant glimmer. That modesty suits its name. In old stories, Orcus was a quiet god of the underworld, not flamboyant like Pluto or loud like Hades, but inevitable, waiting, not chasing. The world that wears his name behaves the same way. It does not blaze, it does not perform. It keeps the time it was given and moves in grace through the dark. If you could kneel on Orcus's surface, Vanth would loom in the sky, large as a promise, almost half the horizon's width when it rides high. The sun would be sharp and fierce. Nothing like a disk, just a bright point that refuses to soften. The stars would hold steady, with no atmosphere to turn them to sparkles. Gravity would greet you gently, a tenth of Earth's, so every step would lengthen into a soft arc, and every hop would ask whether you meant to leave. The ground would be dark, crusted with frost that crunches like sugared glass. Even your shadow would feel slow, as though it had extra distance to travel. Peace would not have to be earned. It would simply be the default. Orcus, in its way, is a kindness in a system built from collisions. It offers balance. While Pluto plays the loud theme with its bright planes and its dramatic close-ups, Orcus carries the counter-melody low, steady, and exact. A reminder that a harmony can exist without applause. Seen from far above, both worlds move like a pendulum in deep space, one forward while the other back, then trading places, keeping time long after our calendars are forgotten. Just beyond, where the Kuiper Belt thins into a quieter array of ice and rock, another small world glides with a name that carries music in its syllables. Quao-ar, pronounced softly, Qua-o-ar. The name comes from the Tongva people of Southern California, who told of a creative force that sang the first beings into the world. It fits the way this object feels in the mind, not grand, not insistent, but humming through centuries as if a song could sculpt patience. Quao-ar entered our ledgers in 2002, again, through the careful work of Chad Trujillo and Michael Brown. At the time, it was among the largest known Kuiper Belt discoveries, and hinted that the outskirts were far busier than we had guessed. About 1,100 kilometers across, larger than Ceres, and with enough gravity to round itself, Quao-ar sits just beyond Pluto's track, a near-dwarf world with quiet authority. Its surface is dark, reflecting roughly a tenth of the sunlight it receives. But dark here does not mean featureless. Spectra show water ice peeking through the gloom, methane frost laid thin in places, and the reddish-brown veil of tholins settling like old varnish. Radiation paints. Small impacts scrape and refresh, and the result is a face that is mostly old but not entirely surrendered to age. Now and then, something sands it to a faint glimmer. The excitement may run deeper than the skin. Some lines of evidence suggest a chance, only a chance, but an intriguing one, that an interior layer of slushy water could persist far below, wrapped in insulating ice and kept near melting by the quiet decay of radioactive elements in a rocky core. No geysers shout this secret, no cracks spill proof to space. It's a hypothesis shaped by density, by the behavior of similar bodies, and by the solar system's habit of hiding small oceans in unlikely places. The idea that a world so far away, so cold, might still cradle liquid is the kind of thought that warms without raising the temperature. Then Quaoar surprised everyone in a new way. In 2023, observers found a ring, thin, faint, and lovely, circling at a distance that seems to break a rule. Rings usually live within the Roche limit, where a planet's gravity prevents loose chunks from clumping into a moon. Quaoar's ring orbits well outside that boundary, in a region where ice and rock ought to gather and become a small satellite. Yet the ring has not collapsed. Something holds those particles in place, perhaps resonances with a tiny unseen shepherd moon. Perhaps the narrow rhythm of orbital speeds itself. Perhaps some delicate interplay we have not named yet. Whatever the reason, the ring remains as a pale thread of frost. A halo that should have ended and hasn't. A note sustained long past its expected fade. Quaoar's year measures in centuries, about 286 Earth years for a single loop, and its seasons likely linger for decades at a time. Nothing here is quick except starlight. The world moves like a dancer who knows her tempo and refuses to hurry just because an audience wants a faster song. If you wandered there in imagination, the sun would be a hot star rather than a disk, the sky a sheet of unsoftened black. Gravity would be a fraction of home, on the order of 1/12. So walking would become a series of slow flights, and landing would feel like a suggestion. The ground would be dusky, sprinkled with faint frost. If you looked sideways across the horizon at the right moment, you might catch the ring as a pale, horizontal gleam, a line so thin you'd wonder whether your eyes had invented it to keep themselves company. Quaoar belongs to the quiet majority, the building blocks that never quite built. It carries the leftover ingredients from the sun's early kitchen, the same stock that fed the larger worlds and then remained, unwasted, to circle in the dark. That endurance is a kind of beauty. No storms boast, no plumes roar, no headline demands attention. The world rotates, reflects a little light, keeps a long appointment with the sun, and wears a ring that should not persist, but does. The Tongva story weaves well with the physics, a creator that sings things into being, a world that seems to hum along, turning slowly, while a halo keeps time. Think about the comfort of such steadiness. In a system where some objects flash by, where comets flare and fade in one lifetime, where gas giants spin storms as wide as continents, it helps to know there are places that simply continue. Orcus keeps balance with Pluto without ever touching it. Quaoar keeps a ring at an impossible distance and doesn't let it fall into order. Neither asks to lead. Both are content to keep rhythm. They are the soft beats beneath the melody, reassuring because they do not change with every bar. Picture yourself between them, drifting. Behind you, Orcus and Vanth pirouette through a 10-day duet, mass and motion trading glances across a gap of space. Ahead, Quawa turns with a velvet patience, while the ring writes a fine circle around a darkness that will not brighten. The sun sits far off, a steady pin. The stars are so sharp they feel like they might cut your glove if you reached. Your breath fogs your visor for an instant, then vanishes to nothing. There is no wind to carry a grain of frost, no murmur to pretend company, only the unbothered hum of distant physics. And in that hush, the thought arrives that harmony does not need noise. Balance does not need applause. A world can be a whisper and still hold a truth. Pluto draws the eye, and rightly so. Its mottled plains look like maps of emotion, its portraits close enough to feel like a handshake. Yet while we've been watching, the mirror across the dark Orcus has been keeping time, tracing the same rhythm from the far side of the Sunday. And farther still, the quiet singer, Quawa, holds its fragile ring in a place no ring should last, as if to remind us that rules explain most things, but not all, and that the universe still saves room for wonder. The outer system's strangeness isn't always dramatic. Sometimes it's simply correct, small, balanced, enduring, quietly magnificent. So the pendulum keeps swinging. Orcus and Pluto trade warmth and distance. Frost migrates. Hidden oceans sigh in their sleep. Quawa circles, its ring whispering grain by grain, a line forever drawn and redrawn. Nothing pleads for attention, nothing hurries. The calm is the meaning. Even here at the edge, where sunlight is only suggestion and time moves like a glacier, the cosmos keeps its order without noise, and in that quiet, something like peace accumulates, soft as breath, certain as orbit. Beyond that gentle stillness, the dark deepens. Far out in the Kuiper Belt's dim corridors, where the sun is no more than a sharp glimmer pressed into black, a small crimson world tilts through space at its own angle. It moves slowly, almost shyly, on a diagonal that cuts across the flat plane of the planets, as though it had chosen a quieter road. Gong Gong, one of the reddest wanderers of the outer system, drifts there like an ember that forgot to fade. Its isolation hums rather than empties, a silence that holds presence, a hush so deep you can almost hear the slow breathing of space itself. It first showed itself in 2007 as a barely there speck sliding against a star field, noticed by careful eyes sifting digital images from Palomar. The speck moved too slowly for anything nearby. That slowness was a distance written in motion, more than 85 astronomical units from the sun when it was found. With more nights and more measurements, its path resolved, and its size came into focus. A dwarf planet of about 1,230 kilometers across, kin to Pluto's quieter cousins. Its orbit is peculiar, and proud of it stretched from roughly 34 AU at the warmest to beyond 100 AU at the coldest, the whole ellipse tipped by more than 25 degrees from the solar system's main plane. One circuit takes more than 550 years. Numbers like that are less a clock than a calendar you can open only once in a lifetime. The slant hints at a history you can't see. Long ago, when the neighborhood was still loud with collisions and close calls, something may have struck Gong Gong off-center, nudging it onto this crooked loop. Not a wreck, but a reroute, the kind of event that leaves a scar you notice only if you know where to look. Its color holds the older part of that story. The surface is a deep, dark red, more saturated than almost any large object out beyond Neptune. Cosmic rays and ultraviolet light have been working on its ices for ages, breaking simple molecules apart and knitting the pieces into long, tarry organics called tholins. Layer after layer, that chemistry, paints the ground with a lacquered red-brown. Methane likely coated much of the surface once. Radiation worried at it, left darker residues, and keeps deepening the tone even now. A world painting itself, very slowly, under a trickle of light. Gong Gong is not entirely alone. In 2016, a small moon came into view, Xiangliu, named for a many-headed serpent from old stories. It's modest, around 200 kilometers wide, circling at roughly 15,000 kilometers out, a copper-tinged bead looping a red stone. Watching Xiangliu's dance lets us weigh Gong Gong and learn that it carries more rock than pure ice would allow. Some suspect the moon may be a splinter from that ancient strike, flung away and later coaxed into orbit, a partner born from the same moment that tilted the path. The days here are long and very quiet. A spin takes about 22 hours, and the seasons are stranger still. With the orbit tipped and the axis likely inclined, a pole can sit in low sun for centuries, while the other drowses in unbroken night. Ice migrates at a glacial patience, sublimating in weak warmth, refreezing in darkness, creeping from cap to cap over epochs. Somewhere on Gong Gong this very second, a sunrise may be spreading that will outlast the length of recorded history. Temperatures sink to around 230 degrees Celsius, far too cold for any gas to play at being air. If there was ever an atmosphere, it has fallen back as frost. The stars above are painfully sharp. There is no wind, no rustle, no sound to smudge the edges of silence. And yet nothing about it feels broken. The orbit is odd, but the motion is smooth. It glides the way a marble glides, when the table is perfectly level. If you could stand there, the sun would be a fierce star, not a disk. Xiangliu would rise like a dull copper coin and cross without hurry. Gravity would welcome you gently, each step a small bounce, each landing a soft press into ancient red frost. The ground would crunch like sugared ice. Your shadow would stretch thin and sure, moving only as you move, because nothing else does. The quiet would be complete enough to hear the small noises of your own comfort. A breath, a heartbeat, the soft metronome of a warmed suit line. Most dwarf planets keep close to the solar system's flattened sheet. Gong Gong seems happy to ignore the pattern. That refusal to align is part of its spell. Not bizarre in shape or size, only content to wander on its own slanted stage. Even its name leans into that personality. In Chinese myth, Gong Gong is a red-haired water spirit blamed for knocking the heavens askew. The pairing feels right. A crimson world on a tilted path, not raging, not demanding, simply tipping the story a few graceful degrees. Like many small, cold bodies out here, it is probably a leftover, one of the building blocks that never quite finished the job. It outlasted the chaos that birthed the planets, kept its distance while the inner worlds melted and scraped themselves into continents and seas. It took the long route through time and ended up with a surface that reads like a palimpsest of sunlight and space weather. There's a low-key beauty in that, a world that didn't need to erupt or roar to become interesting, that simply kept turning while the universe hurried around it. Beyond Gong Gong's path, the quiet thickens. The solar system doesn't end after Neptune. It frays into a wide, dim archipelago. Small, shadowed spheres drift through that cold, a family so large we've met only a fraction. Among them, Salacia orbits at about 43 AU, named for a sea goddess, which fits a world adrift on the sun's faint tide. It's on the order of 850 kilometers across, a size that makes it comparable to a state on a map and large enough to hold itself round. It keeps a moon, Actea, and together they move like a paired shell and pearl, dark enough to hide, reflecting only about 4% of the light that touches them. That low albedo hints at an old surface coated in radiation-darkened ice and organics, a canvas that hasn't felt a fresh brushstroke in a very long time. Salacia may already be round enough for the quiet title of dwarf planet, even if the official paperwork hasn't found it yet. Another neighbor, Varuna, is smaller, around 650 kilometers, but livelier in one narrow way. It spins in roughly 6 hours, quick enough that centrifugal force has stretched it into an oblong, as if a water balloon had been tossed in slow motion. The surface shows water ice threaded with darker, carbon-rich material, a contrast you can't see from here but can read in the spectrum. That speed is a kind of balance, not frantic, simply fast enough to be a different shape and still hold together. Ixion, named after a mortal, bound to a flaming wheel, keeps a path like Pluto's, a member of the Plutinos locked in a 2 to 3 resonance with Neptune. It's roughly 700 kilometers across, dark, with a reddish cast, tholins again, painting patience into the ice. If Pluto is the loud, photographed lead in that resonance, Ixion is the steady cousin, keeping tempo from the back row. The orbit leans, the color deepens, and the years arrive like snow, one flake at a time, until the drift is taller than memory. There is Varda, about 700 kilometers wide, traveling with a small moon named Ilmari, both names drawn from stories that like to put light in the hands of makers. Their surfaces carry water, ice, and dark organics, the same grammar in a different accent. Huya loops on an eccentric path, reddish and dim. A body called Chaos tracks just beyond Pluto, with a name that ribs you gently, because the orbit is, in truth, steady and well-behaved. There was, for a while, a discovery nicknamed Snow White, that defied its own title by being anything but white, pale red, under thin frost, a reminder that nicknames are often just placeholders for better understanding. One by one, they appear in our records as dots and grow into worlds you can almost picture. One by one, they return to being dots when the night's observing run ends. All of these small worlds point to a larger truth. Our best telescopes see only so much, and only when an object happens to be near its closest point to the Sunday past, that faintness wins. Below a certain size and brightness, bodies slip back into the starfield and become guesses again. The census is partial. The Kuiper Belt and the regions beyond likely hold hundreds, perhaps thousands, of objects as large as the smaller dwarf planets. Some may be bigger than Pluto. Some may be no larger than Ceres. Most are nameless for now, tucked back into the black, waiting for a survey to pan past the right patch of sky at the right time. The solar system we carry in our heads, the neat diagram with 8 circles and a cheerful sun, turns out to be the bright foyer of a much bigger house. The attic is full, the basement is deep, the yard extends farther than we can mow. Whispers travel in that yard. Some astronomers see hints in the orbits of these distant dwarfs, alignments and stretches that don't quite settle, and wonder about a hidden shepherd, a hypothetical Planet 9. In sketches and simulations, it would be several Earth masses and hundreds of astronomical units away, heavy enough to nudge, slow enough to be nearly invisible to current searches. No one has seen it. It remains a careful maybe, a rumor with math behind it. Whether it exists or not, the idea says something lovely. Our map might still have blank spaces in a place we thought we knew. the dark beyond Neptune isn't just empty, it's uncharted. What we do know is already humbling. Salacia, Varuna, Ixion, Vada with Ilmare, Huya, Chaos. These are the visible tips of an unseen berg. Beyond them, the distribution widens into a sphere that dwarfs the inner system. A quiet crowd keeping the first ingredients of planet-making in cold storage. They do not roar. They don't peel storms across their faces. They keep time instead, centuries to a season, millennia to a story, each world a page from the earliest chapter, never torn out, never heavily edited. Imagine that hidden archipelago as a slow choir. Gongong's note is deep and red, held with an unwavering breath. Salacia hums, almost under hearing. Actea rounds the tone. Varuna adds a quick pulse without raising its voice. Ixion keeps the resonance. Vada and Ilmara braid a harmony. Huya colors the chord. Chaos gives it a name that makes you smile. Farther out, the possibility of a conductor lingers, a planet that may or may not be there, shaping the rhythm. You don't need to see a baton to feel timing, and you don't need certainty to feel wonder. If you close your eyes and stand the way you did on Gongong, feet quiet on frost, sun a pin, stars etched into silence, the scale of it all feels less like distance and more like ease. The solar system doesn't hurry you. It lets you breathe at the pace of cold places. It lets you count with bigger numbers without forcing you to hold them all at once. Worlds keep their orbits regardless of what we call them. They don't require our attention to continue. They simply accept it when it arrives. That acceptance is the comfort. The small red marble keeps leaning along its tilt. The faintly ringed and the faintly paired bodies keep circling. The dim ones we haven't found yet keep existing anyway. The neat clockwork we learned as children blooms into a library with more shelves. The bright volumes stand in front. The back stacks are dusty and rich, full of footnotes that can, together, change the story. Out on the edge, where sunlight is a suggestion and time gathers like snow, the forgotten worlds are not lost. They are simply patient, turning softly and keeping their places until we are ready to notice. Beyond Neptune's path, the solar system doesn't stop. It thins into hush. Light loosens. Heat becomes an idea, and a wide ring of small, icy bodies circles in slow silence. This is the Kuiper Belt, a countryside of space that begins just past 30 astronomical units from the Sun and stretches at least 50 AU farther, a broad, dim lane left over from the time when planets were still learning their shapes. If the inner system is a bright city of worlds, metal, rock, weather, noise, this is the quiet edge of town, wide, cold, full of old things that never needed to change. Its name carries a history of guesses and patient proof. Mid-20th century astronomers, Gerard Kuiper among them, suspected a reservoir of small frozen bodies beyond Neptune. He wasn't the first to imagine such a region, but his name clung to the idea. When the first objects beyond Pluto began to show themselves in the 1,990 seconds, tiny moving points that refused to sit still with the stars, the term took root. Since then, thousands have been catalogued, and the sober estimate is that there may be billions, quiet remnants from the solar system's youth still orbiting where they were set down. Picture the beginning. About 4.5 billion years ago, a disk of gas and dust wrapped the newborn Sunday. In the inner warmth, rock and metal survived, clumping into boulders, then into worlds. Farther out, where cold, preserved water, methane, nitrogen, and carbon-bearing ices, the giant planets rose, sweeping up most of what they touched, not all. Many icy planetesimals were nudged or flung outward by Jupiter, Saturn, Uranus, and Neptune, tossed into distant ellipses like pebbles from a slow slingshot. The Kuiper Belt is where those survivors settled planet seeds that never found enough to grow, archives shelved before the book could be finished. Most Kuiper Belt objects are small, tens to hundreds of kilometers, and irregular, a mixture of frozen water, methane, nitrogen, and other ices threaded with rock. Cosmic rays and ultraviolet light work on them for ages, breaking simple molecules and knitting the pieces into dark organics called tholins. Surfaces stain from gray to brown to ruddy. A few bodies grew large enough for gravity to pull them into spheres: Pluto, Eris, Haumea, Makemake. But they are the outliers, elders in a population of fragments. Stand on one in your mind. The nearest neighbor might be millions of kilometers away, no brighter than a stubborn star. Space dominates here. Fantasy loves crowded asteroid fields. Reality offers distance. The belt is full and empty at once, countless bodies scattered through billions of cubic kilometers, each keeping to its own slow ellipse. Collisions are rare and polite, more the bump of two drifting icebergs than a firework. Over eons, those nudges and tiny strikes sand surfaces smooth, fling a little fresh frost into space, and start again. Grain by grain, a gentle erosion. Sunlight is weak this far out, hundreds of times dimmer than on Earth. It illuminates more than it warms. Temperatures hover near 200 degrees Celsius. Any air that might try to form quickly falls back as frost. No wind combs the dust. Craters can keep their edges for billions of years, unsoftened by rain, unblurred by weather. The belt becomes a museum. The artifacts remain in their cases. Time passes outside more than within. Because it is pristine, the Kuiper Belt gives scientists a first draft of the solar system to read. These objects have changed little since they formed. Their ices and organics are the same ingredients that help seed the inner worlds. Comets and small Kuiper bodies likely delivered a portion of Earth's water and carbon chemistry. It is a steadying thought that something so quiet and far could have had a hand in oceans, in air, in the first patient reactions that made life possible. For a long while, Pluto stood alone in our charts, discovered in 1930, a solitary mark on the edge of the map. Then the 1,990 seconds opened the sky with new detectors and new surveys, and one after another, dim dots began to move. Quaoar, Varuna, Ixion, Haumea, Makemake, Eris. The list lengthened, and the picture changed. Pluto was not the oddball. It was the first neighbor to wave. The solar system's border was not a thin line. It was a wide, old hinterland. Not all members of this hinterland behave the same way. Some are classical Kuiper Belt objects, pacing nearly circular, stable paths that may have shifted little since the beginning. Others are resonant. Their orbits interlock with Neptune's in repeating ratios. Pluto is the famous example, a 2-to-3 resonance, 2 orbits of Pluto for every 3 of Neptune's. Even though their paths cross in distance, the timing prevents close encounters. It is a gravitational waltz that keeps the dancers from stepping on toes. A third group blurs the belt's outer boundary into farther dark. The scattered disk bodies on elongated, tilted orbits, sent outward by past tugs from Neptune, looping far before drifting back again. Together, these icy travelers look less like a wall and more like a gravel path, left by the builders when the great planets finished their work. Look down from above in your imagination, and the Kuiper Belt would appear as a broad, thin ring, dusted with points, each moving at its own unhurried pace. Beyond that ring, the darkness deepens. The scattered disk stretches farther still. Beyond even that may lie the Oort cloud, a vast spherical halo of icy bodies marking the outermost whisper of the sun's pull. The belt is only the inner edge of an unseen architecture, a faint veil between the known rooms of our house and the open night beyond. Its beauty is quiet. No storms roar, no rings blaze across the sky. It drifts like the lingering breath from the solar system's creation, cold, patient, content to keep circling. Each tiny world is a sentence fragment left in place and still legible, while the inner planets flare with activity and the giants braid winds into bands. The Kuiper Belt keeps a slow time, holding the memory of how everything began. Past that soft ring, neatness fades, orbits twist into wild, tilted loops. This is the scattered disk, a ragged region where the sun's gravity still speaks but no longer insists. Bodies here are flung far and wide on long, thin ellipses, arcing into deep dark before falling back again. Exiles who never quite leave and never quite belong. Unlike the belt's gentle plane, the disk is untidy. Objects swoop at steep angles above and below the ecliptic, some tilting as much as 40 degrees. Their paths can carry them hundreds of astronomical units out before the sun gathers them inward. The distances between neighbors expand into billions of kilometers. Loneliness becomes geometry. Eris is the most storied of these travelers. Its 557-year orbit spends much of its time well beyond the belt, out toward 100 AU at aphelion, back near 37 AU at perihelion. At the far end, the sun is a fierce star, and nothing more. Light takes nearly 9 hours to arrive. Eris is not alone. Dozens share the disk's temperament. 2004, XR-190 earned the nickname Buffy for its oddly high inclination. 2007 TG-422 follows a staggering to 1,400-year path. Each one sketches a separate compromise with gravity and distance, a private ellipse in an almost empty sea. The scattering began when the solar system was young, and the giants wandered. Jupiter and Saturn traded places inward and outward, like slow anchors testing the bottom. Neptune likely migrated outward, plowing through the disk of icy planetesimals like a careful snowplow. Objects that strayed too close caught a gravitational shove and flew into stretched orbits. Some were thrown away entirely, ejected into interstellar space. Others found stable loops so elongated and tilted they hardly seemed to belong to the same family anymore. Those are the survivors we see sparks frozen in midair. There may have been other hands on the fabric. In the sun's nursery days, when it shared space with many sibling stars, a close flyby could have tugged at the outskirts and planted the seeds of the scattered disk. Some imagine a forgotten planet, a rogue ice giant briefly roaming the outer system, stirring paths and then moving on. Whether the chief sculptor was Neptune, a passing star, or a lost world, the result is the same: a population written in ellipses, each one an accent mark on the edge of the sun's domain. The disk is not crowded. It is almost hauntingly empty. A single object may turn for centuries without coming within sight of another. Sunlight does not warm so much as reveal, glinting off patches of methane ice or water frost before sinking back into black. Surfaces remain in deep cold, their ancient craters sharp, their dust unmoved by breeze or rain. Motion becomes delicate out here, as if time itself were careful where it steps. Time stretches in other ways too. Pluto measures a year in just under 248 Earth years. Many scattered disk objects count in thousands. They spend long spans near aphelion, nearly still, then fall inward like patient comets that never quite grow tails. To track one is to watch the solar system breathe in units that ignore our calendar's eras instead of years. These bodies likely mark the doorway to the farthest architecture, the Oort cloud, the imagined sphere that may surround the sun with 1 billion tiny nuclei, the seed bank for long-period comets. The Kuiper belt shades into the scattered disk. The scattered disk shades into that halo. The halo shades into the interstellar dark. No hard borders, only gentler and gentler pulls. It helps to hold one image. You're standing on a small, dark object in the belt. The sun is a sharp coin you could hide behind a fingertip. The nearest sibling is invisible, though you know it's there, millions of kilometers away. Your boots press into frost that has kept its shape for longer than language. Over the horizon, nothing rises. The sky is full and silent. Farther out, a scattered disk wanderer moves through a piece of its ellipse you will never see complete. It will be near perihelion when your great-great-grandchildren are memories. It will be near aphelion when names have changed and the constellations have barely shifted. The map we inherit as children, 8 planets circling a bright star, remains true and too small at once. Beyond it, the Kuiper belt keeps the ingredients. The scattered disk keeps the edits. Together, they turn a tidy diagram into a story with a long, quiet second act. They don't need to be loud to matter. They keep their places, and by keeping them, they let us remember how everything started. A disk, a chill, grains that learn to cling, worlds that learn to hold, and, past the finished planets, a population of survivors still circling in the dark, patient as winter, exact as orbits, beautiful in the way that things are when they refuse to hurry. Some of the long-period comets that sweep through our skies may begin life as quiet bodies in the scattered disk, nudged outward over ages until they drift into the Oort cloud, then, after 1 million unhurried years, jostled inward again by a passing star. In that sense, the scattered disk is a threshold, a twilight porch between the rooms we know and the night outside. The sun's grip is softer here. The galaxy's hand is felt as a suggestion. Finding these objects is hard work. They are small, dark, and far. The kind of neighbors that barely shift their position even over years of careful watching. What we've found are the confident few, the brightest, the nearest, the lucky ones that wandered within range of our mirrors. Each new dot moves the map's edge a little, like ripples widening from a pebble's fall. And yet their orbits, however wild, are not random. They are fossils of a loud youth, tilted and stretched by ancient encounters, records of brawls that ended long ago. Seen as a whole, they form a loose halo, a counter-melody circling the sun while the planets carry the main theme. They are outward echoes of formation, still wandering where they were thrown, still loyal to the faint warmth that also lights our oceans and pushes green into leaves. It is easy to forget the kinship. Their distances make them feel detached, like thoughts that have drifted out past speech. But the same sunlight that glows on your window travels, thin as silk and just as persistent, all the way out to those dim ellipses. Even where order, phrase, and paths look feral, the system holds them lightly. They roam. They do not leave. Beyond that scattered edge lies a realm so distant and so quiet that no craft has touched it and no telescope has seen its members one by one. We call it the Oort cloud. If it exists, and the sky's patterns argue that it does, it is the solar system's outermost veil, not a ring but a sphere, a frozen halo surrounding everything familiar. At its scale, the sun shrinks to a bright star among others. The comforting geometry of a family portrait dissolves into a field. We infer the cloud the way sailors infer currents, by what they carry. Long-period comets arrive on orbits too long and too deep to come from the Kuiper belt or the scattered disk. Some take millions of years to complete a single loop. The simplest reading is a reservoir far beyond Neptune, a slow crowd of icy bodies occasionally stirred inward by a flyby star, or by the gentle tide of our galaxy's gravity. If that reservoir is real, it is enormous. Imagine boundaries place its inner edge around 2,000 astronomical units, and its outer edge out toward 100,000, 3,000, Pluto's stacked end to end. At those distances, the sun's pull is a whisper. Past the far rim, other stars ask stronger questions than ours. Within that bubble might drift trillions of icy bodies, most no bigger than hills, many only a few kilometers across. Picture admixtures of water ice, methane, ammonia, and dust. The same raw ingredients that fed the planets when everything was still loud. In the early days, as the giants grew, they flung countless planetesimals outward. Most slipped free and were lost to the interstellar dark. A fraction stayed bound, barely, settling into a spherical cloud that time rounded at the edges. Passing stars brushed it. The Milky Way's tidal pull breathed on it. The result would be a diffuse shell that has floated ever since, almost untouched. To stand on one would be less standing than balancing on a moving ice raft. The sun would be a fine, sharp star, brighter than most, but not imperious. The nearest neighbor might lie millions, even billions, of kilometers away, present in calculation, absent to the eye. The surface would be old ice, with a memory for impacts, crisp-edged craters, dust untroubled by weather, shadows that keep their shape for epochs. Time would stretch until the word lost meaning. In the outer cloud, a single orbit could require tens of millions of years. Even the inner cloud would count in millions. Compared to this, the familiar planets are bees in a sunlit garden. All hum and hurry. Every so often, the quiet breaks. A star wanders near, not very near by neighborhood standards, but close enough over cosmic distances to tug on a handful of fragile paths. The galactic tide leans a little. A few bodies tip inward and begin to fall, taking long, cold centuries to gather speed. At last, they cross the orbits of the giants, approach the sun, and learn to shine ices sublimating into a coma and tail. Old dust turning into a brief, beautiful signature across our sky. Then they leave. The show is short. The journey is long again. These comets are messengers from the halo. They carry ancient material unchanged by the heat of planets, water, carbon compounds, complex organics, the same chemistry that may have helped seed Earth. Each time a comet appears, a bit of the cloud becomes visible, says hello, and returns to the deep. Elusive is too simple a word for the cloud. It is both our largest structure and the one most likely to remain legend, confirmed by evidence, not by sight. The objects are too distant and too small. They reflect too little. Their motions are too slow. Their arcs too shallow to track in a lifetime. We know the cloud as oceanographers know gyres, by where the flotsam came from, and the curves that debris insists upon. The comet paths point back to a shell of origins. They are arrows from a hidden shore. There is a beauty to the scale. The inner solar system, the belt, the scattered disk, these are lit rooms. The Oort cloud is the dark cathedral around them, vaulted and silent. It does not churn or blaze. It floats, a few light years wide. It lives where the sun's influence fades into the galaxies, and where boundaries blur into gradients. Some astronomers suspect the far edge of our cloud may overlap with other stars' clouds. In a crowded nursery long ago, stars may have traded comet seeds the way neighbors trade stories over a fence. If so, the halo is not only an edge, but a mingled border, ours and not only ours. We have not reached it. Our most distant probe, Voyager 1, has traveled beyond the solar wind's breath into interstellar space more than 160 astronomical units from the Sun, and still sits far this side of the cloud's imagined inner shore. It will take tens of thousands of years to pass that threshold, and when it does, it will slip between objects so far apart they will not notice it passed. No plaque will mark the crossing. Quiet will remain quiet. Even so, the cloud matters. It reminds us the solar system is not a tidy tray of marbles. It is layered. A bright hearth at the center, a wide ring of old ingredients, a ragged porch of scattered wanderers, and a cold, unseen halo where home brushes against the between. The sun's reach is longer than instinct allows, and yet gentle at the edge. A parent who lets the oldest children live far away and still calls them by name. That is the tone out there, faint, persistent, unboastful. The scattered disk, for its part, is the mid-story that links those rooms. Long-period comets can be born there, nudged outward to join the cloud, then coaxed inward again by the slow choreography of tides and flybys. The objects we've found are only a sampling, the readable lines on a page mostly blank. Their orbits look lonely, but together they sketch a kind of balance, a diffuse halo answering the neat circuits of Mercury through Neptune, a counterpoint that keeps the music from becoming a march. Imagine, finally, the scale from above. The sun glows at the center like a coal. The inner planets whirl, bright and busy. The Kuiper belt is a thin, far ring dusted with stair-step light. The scattered disk spreads beyond it in tilted strands, and then the halo, vast, faint, almost entirely suggestion, encircles everything. Somewhere within it, a small body begins to fall, pulled by an arithmetic older than language. Somewhere nearer, a scattered object inches along the slow part of its ellipse. Somewhere here, a comet lifts a tail over a city, and people look up and feel both very small and very lucky. The same system holds all of it: warmth and water and crops, dim ice and organics, old paths and newer names. The same light touches your face, and a dark, drifting speck at the edge of the sun's reach. If you listen, the lesson is soothing. The outer dark is not absence. It is structure we cannot yet resolve, patience we can only describe. The scattered disk waits without complaint. The Oort cloud, if it is there, waits without even the need for waiting as a word. Our charts will sharpen, our reach will lengthen. For now, the long-period comets are enough. They arrive glowing like breath in winter air, tell us that home is larger than we thought, and slip back to the cathedral, where ice keeps its counsel and time learns to move in millennia. Before the family of worlds felt familiar, everything was softer and less sure. A newborn sun burned behind a veil, and around it drifted a wide, slow disk of dust, ice, and gas. No planets, no moons, no comets, only motes in warm light so small they would vanish on your fingertips, circling in a glow like breath on glass. Yet inside that haze was everything. The stone of mountains, the salt of oceans, the iron of blood and basalt, all the unborn scenery of night, waiting to settle. Growth began with almost nothing, grains rubbing, kissing, clinging by tiny static charges, gathering into downy clumps that barely deserve the word together. Most meetings ended in breakage, but the disk had patience to spare. Over millions of quiet tries, some clusters survived. Gravity weak at first, then a little stronger helped them collect more. Pebbles became boulders. Boulders became hills. Hills became mountain-sized bodies with their own small pull. Planetesimals, the seeds of worlds. The early neighborhood was crowded. Countless planetesimals traced overlapping paths, merging when they met gently, shattering when they arrived too fast, feeding a cycle of assembly and rubble that felt like a construction site and a demolition derby at the same time. With each impact, energy turned to heat. Radioactive elements inside the larger ones gave off warmth too. The biggest seeds rounded themselves under their own gravity, and the hot, heavy parts sank inward, while lighter materials floated up. Cores formed, mantles gathered, skins of rock and ice cooled. What began as loose piles became layered bodies with personalities. Closer to the sun, material was dense and dry enough for growth to move quickly. The winners there swept their lanes, pulling or flinging smaller neighbors away until the space around them belonged to them alone. Farther out, the disk thinned and chilled. Distance stretched between collisions. Accretion slowed. Plenty of planetesimals never collected enough to cross that invisible threshold of dominance. Some drifted inward and were captured as moons. Some met a giant at the wrong angle and were tossed outward into long, tilted paths. Some simply stayed where they were, small and steady in the outer dark. These are the forgotten worlds, dwarf planets, and icy remnants that paused early and never needed to resume. Forgotten doesn't mean failed. Their smallness makes them precious. Fossils of the system's childhood, pressed in ice. The big planets went on to repave themselves. Oceans poured and withdrew. Volcanoes breathed. Plates slid. Atmospheres thickened and thinned. The dwarfs, meanwhile, kept their first stories. Ancient craters sit crisp along their faces. Interiors hold the arrangements they learned billions of years ago. To study them is to hold a rough draft of a chapter before the edits. There were near misses everywhere. Some bodies grew almost large enough to become planets, only to be shattered back into rubble by an untimely hit. Others might have made the leap if they had formed a little closer to the sun, where growth was faster. A few were surely en route before being flung into exile by migrating giants. The sky is full of what-ifs. Worlds that almost were, paths that almost happened. The dwarfs we see are the survivors of those close calls. Roundness, too, carries a quiet line. A body becomes spherical, enters hydrostatic equilibrium, only when its gravity is strong enough to smooth away stubborn hills. Cross that boundary, and you join the company of rounded small worlds. Ceres in the asteroid belt, Haumea, Makemake, and Eris in the far cold. Most of their neighbors never reached it. They remain irregular, like shards of pottery tumbling at the edge of sunlight, every facet honest. Farther out, some planetesimals became the hearts of giants. In a season that did not last long, before the young sun's wind swept the gas away, a few cores grew fast enough to pull in thick blankets of hydrogen, and helium, Jupiter and Saturn ballooned, then stopped. Others gathered thinner envelopes and became ice giants, Uranus. Neptune blew with cold chemistry. When the gas cleared, no latecomer could repeat the trick. The window closed, the giants rose quickly. The dwarfs lingered, steady and small. The difference between planet and dwarf planet isn't a simple size contest, and that subtlety can be soothing. Pluto, smaller than Earth's moon and yet active and complex, reminds us that scale doesn't dictate character. The line is about dominance as much as diameter. Planets sweep or sculpt their neighborhoods until they rule their lanes. Dwarf planets never quite tip that balance. They share space with a crowd of peers. If you love theater, imagine the dwarfs as actors who memorized their lines and arrived on time, then weren't cast as leads, not because they lacked heart, but because the stage had too many voices and only a few microphones. So much of this comes down to timing. Slide a few events by a few million years. Nudge a birthplace inward or outward, and the map remakes itself. Pluto might have grown into a modest planet, while Mars stayed small enough to be a dwarf. Ceres might have merged with siblings and become a true world in the wide gap between Mars and Jupiter, instead of the largest resident of the asteroid belt. Haumea might never have been reshaped by the collision that left it elongated and spinning fast. Sedna might have lingered nearer the sun instead of tracing a vast 11,000-year arc. What we see now is a patchwork of victories and accidents, giants that grew quickly, small worlds that never stopped being small. The story didn't end here. Our telescopes now watch other stars cradle their own disks, pale rings glowing in infrared, with gaps where new bodies are sweeping lanes clean. Somewhere in those fogs, pebbles cling and cores coalesce, and a few will balloon into giants, while most remain small, enduring, unhurried. That isn't failure. It's how systems are built, not as perfect sets of equal spheres, but as families, some children loud, some quiet, some staying close, some living far away and rarely writing, but always part of the whole. The forgotten worlds are not afterthoughts, they are foundation, bricks that never became towers, but still hold weight. Without their fragments, the larger planets would have had less to gather. Without their gifts, water, carbon, chemistry, Earth might have lacked the raw material for oceans and the first slow steps of life. Giants may command attention, but dwarfs are the quiet architects of everything that followed. Unfinished stories, yes, but first chapters are where the characters learn their names. For most of human history, planet meant something simple and closer to the eye. The wandering stars, Mercury, Venus, Mars, Jupiter, Saturn, moving slowly across a backdrop that otherwise held still. Telescopes added new wanderers. Uranus at the end of the 1700s, Neptune in the 1800s, Pluto in 1930. The list lengthened, and classrooms raised 9 names like a spell. Then the deep sky widened. New objects appeared beyond Neptune, crowding the edge and blurring categories. The word we loved had never been tightly defined. It had been tradition, more than rule, and tradition began to creak. The moment of decision arrived in 2005, when a distant world, Eris, was announced. Slightly smaller than Pluto in width, but more massive. It felt like a mirror, held to our habits. If Pluto was a planet, surely Eris had to be as well. And if Eris, then what about the others arriving by the dozen? Would planets stretch until it covered 50 names? 100? 1,000? The choice wasn't about affection. It was about clarity that kindness could live inside. In 2006, astronomers with the International Astronomical Union gathered and did the inelegant, necessary work of naming lines. They voted on a definition that asked three things of a planet. It must orbit the Sun. It must be massive enough for its gravity to shape it into a nearly round form. And it must have cleared its orbit, dominated its neighborhood, so that it no longer shared the lane with many siblings. Pluto met the first two. It failed the third. So did Eris. So did Haumea and Makemake. Ceres, inside the orbit of Mars, also fit the in-between. Those bodies became dwarf planets, a phrase that tries to be accurate without unkindness. The count of official planets fell from 9 to 8, posters were reprinted, mnemonics learned in childhood needed new vowels. Feelings were involved. Many people had grown up with Pluto as a small friend at the edge, and the change felt like being told the friend was never quite family. Some scientists pushed back, too, pointing out that clearing the orbit can sound fuzzier than it is, and that Earth shares its path with thousands of small bodies as well. Others answered that without a dominance clause, planet would become a baggy word, losing the precision that lets language do its good work. Underneath it all lay a quiet question. Is a planet defined by what it is, or by how it behaves and where it lives? The IAU's frame tilted toward behavior and neighborhood. Two objects of the same size might wear different labels if one controls its lane and the other does not. It is less a verdict than a map key. Maps change as instruments sharpen. Names change more slowly because we attach memories to them. Through it, Pluto did not shrink, did not dim, did not become less wondrous. Eris did not turn troublemaker. It simply helped us see that our list was a story, not a law. The dwarfs did not move to a lesser sky. They kept their orbits and their mysteries, and in time, they received visits in pictures and spectra. The way New Horizons gave Pluto's heart-shaped plane to our eyes, and dawn read salt and shadow on Ceres's face, the words shifted, the world stayed. When you step back and let the whole picture rest, the comfort returns. A disk turned into pebbles, pebbles into hills, hills into seeds, seeds into worlds, and many seeds into the quiet, enduring population we call forgotten only because we are loud and busy. The giants hold storms like orchestras. The inner planets glow with geology and light, and the dwarfs wait, some bright, some ruddy, some ringed, some paired, keeping first chapters safe. They do not need leading roles to matter. They are the memory of how it began, still turning in the dark, still carrying the steady proof that small things, given time, can shape everything. If Pluto lived alone near Earth's orbit, we'd probably call it a planet without a second thought. Out where it actually lives, in the crowded calm of the Kuiper Belt, it wears a different badge. That choice keeps the list tidy, but it can feel like Pluto was marked down for growing up in the wrong neighborhood. The conversation never really stopped in 2006. Since then, many astronomers have argued for a simpler rule. If a body is big enough to be round under its own gravity, call it a planet and be done with it. By that measure, Pluto would return to the fold along with dozens of other round, quiet worlds. Others suggest stepping around the argument with broader families, planetary mass objects, perhaps, or simply worlds labels that gather planets and dwarfs together and let the details live in the subtext. There are side doors to the debate too. Moons like Ganymede and Titan are bigger than Mercury and more geologically alive than some official planets. Yet they don't get the word planet because they circle other planets instead of the Sunday. Some advocate calling them satellite planets. Others keep planet, reserved for stellar companions only. Even exoplanets were outside the original wording, and only common sense pulled them in. The pattern is plain under the fuss. Planet is not a law of nature, but a human tool. The universe doesn't draw lines. It just makes worlds in many sizes, with many accents, and we draw lines later so our minds can keep track. Our tools change as our understanding widens. Once the sun and moon were planets. Once Ceres and Vesta were planets. Then asteroids. Now Pluto sits with the dwarves. And one day, the roster will shuffle again. The closer we look, the less the solar system resembles tidy boxes, and the more it looks like a spectrum. Some asteroids show traces of old volcanoes. Some comets act like sleepy rocks wrapped in frost. Dwarf planets carry the gravity to round themselves, yet share their lanes with many neighbors. Moons blur categories by being fully planet-like, while bound to bigger companions. Pluto's reclassification was never an attack on a single little world. It was an answer to a flood of discoveries. Eris, Haumea, Makemake, Sedna, and many smaller bodies proving that the far reaches are not a single outpost but an archipelago. The definition changed not to erase Pluto but to make room for everything else. In doing so, it reminded us how thin our labels can be, and how easily they crack when pressed against reality. There's a quiet comfort in that. Words are scaffolding. Worlds endure. Pluto still circles in faint sunlight, its surface bright with nitrogen frost and water ice mountains. Eris still glints beyond, imperturbable. They don't care what we call them. They simply are. The debate, when you listen closely, is a mirror turned on us, our need to sort and name, our wish for clean edges in a universe that loves gradients. The idea of planet has always moved with our vision. It will move again as new worlds are mapped, new moons are explored, and other systems teach us broader possibilities. Someday, our descendants may smile at our 8-planet scheme, the way we smile at star maps with crystal spheres. They may call hundreds of objects planets or none. They may abandon the word and use worlds instead, each one specific, each one itself. Meanwhile, most of the outer family remains unseen, except as faint moving dots. Their surfaces are maps we haven't read yet, their ridges and ridgelines still folded inside darkness. That won't last forever. Curiosity has a long fuse, but it burns steady. We've already taken the first steps. In 2015, after nearly a decade in flight, NASA's New Horizons swept past Pluto and turned it from a symbol into a place. A pale heart of nitrogen ice lay across its face. Mountains of water ice lifted like broken teeth, and a thin, hazy atmosphere reached up in blue layers. No argument could survive that view. Pluto was a world with weather and memory, a story written in frost and stone. New Horizons kept going and, in the Kuiper Belt, met Arakoth, a small contact binary, shaped like a gently flattened snowman, only about 30 kilometers long. It was smooth, lightly cratered, and softly red with ancient tholins. For the first time, we saw a planetesimal, essentially unchanged since the beginning. Two small bodies that once orbited each other drew closer and touched without shattering a handshake, frozen for more than 4 billion years. It was like peeking into a time capsule labeled "How to Start a World." We've tasted closer waters too. Dawn orbited Ceres from 2015 to 2018 and found bright salt deposits against dark ground, likely minerals left where briny water once seeped upward and flashed to vapor. It saw a lone, rounded mountain that looked like the frozen memory of a cryovolcanic sigh. It gathered hints that liquid may still linger far below. So many questions remain. How thick is that buried layer? What chemistry stirs there? How long can such a small body stay warm enough to move? On the sketchboards are missions that lean into the deep cold. A fast flyby of Haumea to read its crystalline skin and slender ring. An orbiter for Eris to weigh it precisely and watch its nitrogen frost gleam and darken. These paths are long. Eris can be more than 14 billion kilometers from the sun. Even at New Horizons pace, the cruise would take decades. But these worlds have waited for billions of years. A few more decades will not test their patience, and it need not test ours if we work in the same quiet cadence. Some imagine swarms of small probes, pushed by sunlight, solar sails catching a pressure you cannot feel, and building speed in silence. Others picture nuclear electric ion drives, engines that sip fuel and trade loud thrust for years of whispering acceleration. There are concepts that use the sun itself as a slingshot, diving close to harvest a deep, bright push before flinging outward on a fast arc. None of it is easy. Once, New Horizons was a drawing on paper, then it wasn't. That is how this goes. Ideas, arguments, engineering, and the steady courage to start something that someone else will finish. The reasons are scientific and human at once. Up close, time becomes visible. A world like Haumea spins so fast that its ice glints in bands. A camera could watch sheen and shadow braid into a pattern. A pass-by Sedna could show a ruddy surface stained by radiation for eons. The sun reduced to a white star behind it. Even in perfect quiet, these scenes would speak. Each flyby would be a field note from the beginning, written in ice. Every frame would sharpen home, too. New Horizons looked back at Pluto and saw a blue haze against the dark. And beyond that haze, a pinprick of the Sunday. That pin is what warms oceans and pushes winds across grass and threads rain into seasons. Seeing it from the outer dark changes how it feels to stand in daylight. The forgotten worlds do not host cities or birdsong. They host context. They remind us how many steps had to line up for breath to exist at all. If patience and technology keep pace with each other, landers will follow the scouts. Imagine a small robot settling onto Makemake's dusky plain, or onto Orcus's dark crust. It would carry a drill to taste the subsurface, a spectrometer to smell ancient organics, a seismometer to listen for faint creaks inside the ice. It would sit for years in the thin sunlight, sipping power, tipping home whispers of data through a sky that takes hours to cross. The probes would fly themselves most of the way, turning, photographing, sleeping, unfolding a world not with drama but with care. That pace matches the places. The outer family doesn't hurry, neither should we. We will learn them on their terms, slowly, kindly. A world will sharpen from a dot to a disk, then to a surface with texture and story. We will meet it as you meet a quiet neighbor, gently and with the understanding that silence is not emptiness, but choice. When the first close portraits of Eris or Haumea or Sedna arrive, something in our map will lift. The edge will feel less like a border and more like a beginning. There will be no emptiness, only old stillness, layered and legible. We'll see that the solar system isn't just a handful of bright rooms near the hearth, but also a long outer hall of embers, each keeping a steady red under frost. And then the names will matter less. We will still argue, because arguing is one of the ways we think, but the frames will sit beside the arguments, like stones beside water, heavier, more patient. Whether we say planet, dwarf, satellite planet, or simply world, the thing itself will go on turning under a pale sun, keeping time with a clock that doesn't need us. The task in front of us isn't to draw a final border. It's to keep learning how wide and strange and lovely our neighborhood truly is, and to remember that wonder takes no account of labels. For now, most of the far ones remain shy, faint points edging across black in our largest mirrors. But a mirror is only a promise made of glass. We will keep the promise. We will go slower. We will listen longer. We will learn to notice what has always been there. Somewhere ahead, a sail will fill, a camera will wake, and a small red world will grow large enough to show its scars. It will not greet us. It will simply allow us to look. That will be enough. In the grand family portrait of our system, the small and far barely register. They don't throw shadows like Jupiter, don't wear light like Saturn, don't shimmer blue like Earth or rust like Mars. They sit at the edges, dim and distant, soft as embers. On first glance, they look like footnotes, fragments that never found a headline, leftovers swept to the rim. And yet, quietly, they carry the longest memory. They keep the ledger of beginnings pressed into frost. Where the big worlds churned and resurfaced, these stayed almost as they were. The scars that pocked them when the sky was crowded with falling stone still ring their faces. Dust older than continents lies undisturbed where sun and time placed it first. If you want to hear how the story opened, you listen where the noise never reached. What they hold is the recipe: water ice, methane, and ammonia, carbon-rich organics, silicate rocks stirred in the first disk around a young star. The planets spent their inheritance. The dwarfs and their kin did not. They stayed small, and in staying small they preserved flavor, the unboiled chemistry, the unspent grains. To taste one would be to sip the early broth of a system, still cold, still simple, still complete. Some of that broth found us. Long ago, when Earth's skin burned too hot to keep oceans, icy messengers from the far ring arrived and fell apart into air and rain. Water gathered, clouds formed, rivers learned their beds. With the water came carbon compounds, patient building blocks that would one day meet sunlight, minerals, and time. It isn't a grand claim to say the outer small made inner largeness possible. It's a plain one. Oceans breathe because quiet bodies kept their promises at the edge. The red varnish that tints so many distant surfaces, tholins born from light worrying methane and nitrogen into long, dark chains, bridges, errors. You can imagine its cousins swirling in early earthly seas. To see that color on Pluto, Makemake, Sedna, Gong, is to catch your own past reflected across billions of kilometers. The way an old melody sounds new when played in another key. The orbits themselves tell a story, too. Neptune's slow outward slide, the way it shepherded some and scattered others. The resonant agreements that keep Pluto and Orcus dancing safely while never meeting. The long ellipses flung into the scattered dark. The deep halo imagined beyond, where the sun's pull thins to a sigh. Those patterns are fossil ripples. Follow them, and the hidden migrations rise out of arithmetic like footprints in dew. There is meaning in their silence. Not everything announces itself to matter. Not everything that matters needs announcement. The small ones keep their places, and in doing so, they show how structure rests on modest things. Their gravities are gentle, but not nothing. They steer dust and comets, nudge paths, set soft terms. Their very existence leans the mind toward proportion. It's easy. standing on a bright world with wind and song to feel central. From the distant dark, Earth steps back into scale. A pale point near a coal of flame, one more light among the common lights. That view isn't bleak, it is relieving. It says that most of what lasts in the universe endures by being quiet. They are beautiful, and the beauty is the kind you learn to see. Pluto's smooth heart of nitrogen, mountains of water ice rising like frozen foam. Haumea turning, lengthened by its spin, glittering with crystalline frost and pranked with a thin ring. Make soft red, a velvet dark that swallows stars. Sedna's wine-stained hue and its 11,000-year patience. Orcus and Vanth keeping steady step from across Neptune's rhythm. Quaoar circled by a ring, where a ring should not survive. Gong, crimson and tilted from the crowd. Vada and Ilmari, Varuna and its quick day. Ixion, chaos. Huya, Salacia and Actaea, the faint uncounted whose names are still waiting on someone's tongue. They are not showy. You have to look twice and longer, and then the quiet resolves. Textures appear, shadows gain weight. A small world takes the shape of a place. That is their gift. They retrain attention. They ask for slowness. Anyone can gasp at rings wide as a planet or a storm that could swallow continents. It takes a different kind of gaze to salute, a dim dot sliding against colder dots, and feel your chest rise. And yet that dot may be older than mountain ranges, richer than epics, carrying a map that can teach us how to begin again. The small ones ask so little and offer so much, a chance to practice wonder on a different scale. They whisper humility. The solar system is not arranged so our categories feel clean. It's a sprawling family, loud and mute, banded and bare, round and irregular, magnetized and indifferent. The same dust wrote all of it. The same light edits all of it. The same gravity keeps the pages bound. To prize only the bright is to miss what survives. To prize only the heavy is to miss what holds. You can go your whole life without standing on Sedna, or watching the sun skim the low horizon of Orcus. Almost everyone will, and they will still enrich what it means to live here. The fact of them increases the room available to meaning. Generosity is everywhere, if you allow it. The disk made more worlds than any one definition required. Some grew large and took the center. Some remained as they were. You could call the small ones forgotten, but the cosmos doesn't forget. It simply files. They waited, and they wait still. And when we turn our heads in their direction, they are there, uninjured by neglect. That, too, is a lesson. Value is not a function of attention. The world does not become a world when we name it. It becomes a world when it holds itself together and circles a light. They are punctuation, the commas, the rests, the long dash that lets the sentence breathe. Without them, everything would be shout and sprint. With them, the story gains contour. They carried water to seas and carbon to soil. They ferried salts and simple organics. They kept a draft of the first pages in case the bound copy burned. They are roots below a garden, bass under a melody, heartbeat under a song. They set the tempo that keeps the bright parts honest. Out beyond the confident planets, the solar system softens into privacy. The sunlight thins. Heat becomes a rumor. The worlds become fewer, smaller, and quieter, as if the orchestra has finished and the whole is holding the last note in the rafters. You have moved among them in thought, Ceres with its salt gleam, Haumea flashing like a cut gem, Make, Eris, Sedna, Orcus, answering Pluto's step, Quaoar with its improbable ring, Gongongs tilted crimson, the many with shy names and the many with none at all. You traced the gravel ring of the Kuiper belt, wandered the wild tilts of the scattered disk, stood at the threshold where the sun becomes a bright star among stars. They aren't places of spectacle, they are places of endurance. The less you insist on being dazzled, the more they give. Their stillness does not scold, it invites. It says that not everything needs to change to matter, that steadiness is a form of grace, that patience is a kind of courage. It says that meaning arrives at many speeds. Out there, a year can stretch into centuries. An orbit can reach beyond language. To meet that cadence, you slow down inside, shoulders loosen, breath takes its time. Perhaps probes will cross the distances more often, sails swelling with thin pressure, ions whispering a long acceleration, cameras waking to catch frost in side-lit relief. Perhaps landers will sit in low sunlight and listen for faint quakes, drill thin cores from red crust, sniff the frozen air that isn't air and weigh the trace. Or perhaps we will only ever greet many of them as moving points. Either way, they remain what they have always been, steady attendants at the edge of light, content to be themselves without audience. Their worth does not wait on our arrival. So, let the noise fade. Let the bright rooms draw you home while the outer halls keep their dusk. See the stars stretch in every direction. See the sun become a silver stitch. See the small worlds hold their ellipses like vows. You pass them in mind, and they grow small behind you, the way all distances do. They do not vanish. They return to their native quiet. They do not mind being left. They do not know the word. They simply continue. Leave them as they are, patient, still, enduring, and take with you what they offered. That wonder scales down. That time can be kind when it is vast. That beginnings are not lost if someone remembers where to look. The bright, roaring worlds will always be there, busy and beautiful. So will these, the ones you almost didn't see, the ones that taught your eyes to soften, the ones that made room for awe in the very far and the very small. The stars keep their places, the edge keeps its counsel, the forgotten worlds keep their slow watch. You turn inward now, unhurried, carrying a thin thread of their light. The journey loosens into quiet. The picture dims like a room with the door pulled nearly shut. Out where the sun is a sharpened pin, and the dark is full of patience, they go on turning. And you, warm in the familiar glow again, know where they are.